Good day, ma'am and classmates. Today we will discuss about the truth tables and tautologies. Here are the objectives. Today we will going to determine the truth value of propositions by constructing truth tables, symbolize proposition using connectives, define tautologies, contingency, and contradiction. Identify if a proposition is tautologies, contingency, and contradiction. The truth value of a compound proposition is difficult to determine because a compound statement may contain true or false statement at the same time. An example is the statement, "It is raining today and classes are suspended." The first part, "It is raining today," could be true, but the second part, "classes are suspended," could be false. In this lesson, we will find out the truth value of a compound proposition, especially if it contains true and false statements at the same time. Pinag-uusapan nito kung paano matukoy ang truth value o totoo o mali ng isang compound proposition. Isang pangungusap na binubuo ng dalawa o higit pang simpleng pangungusap. To identify the truth value of a compound proposition, we construct truth tables. A simple proposition will have a truth table consisting of two rows because its value is either true or false. For a compound proposition consisting of two simple propositions, there will be four rows needed for the truth table. Mahirap matukoy ang truth table ng isang compound proposition dahil maaaring maglaman ito ng parehong tatlo at maling pahayag. Para matukoy ang truth table ng isang compound proposition, gumagamit tayo ng truth table. Ang isang simpleng proposition ay may truth table na may dalawang row, totoo o mali. Ngunit kung ang compound proposition ay binubuo ng dalawang simpleng proposition, ang truth table nito ay may apat na row. Ang presentasyong ito ay nagtuturo kung paano gamitin ang truth tables para malaman kung totoo o mali ang isang compound propositions, lalo na kung mayroon itong magkahalong tatlo o maling pahayag. Here are the example tables. P or not P. The P here in the first column is true, and the not P is false, and the last column of P is false and not P is true. In the second table, the P is true, the Q is true, the P and not Q is true, the P or Q is true, and the P and Q is true. The second column is true, Q is false, P or Q is false, P and Q is true, and the P, Q is true. The last column of P is false, the last column of Q is false, the last column of P and Q is false, the last column of P or Q are false, the last column of P and Q is true. In constructing the truth table of P and not Q, start with proposition first, then add another column if there is a negation of a variables. The last column must be the given proposition. In the third table, the last column of P is false, the last column of Q is false, the last column of not Q is true, and the last column of P and not Q is false. Activity or collaboration. Number 1. Construct a truth table for P and R and Q. The last column of P is false, the last column of Q is false, the last column of R is false, the last column of P and R is false, and the last column of P and R if and then Q is true. Number 2, construct a truth table for Q and R or S and P. The last column of P is true. The last column of F is true. The last column of R is true. And the last column of S is false. The last column of Q and R is false. And the last column of Q and R or S is false. The last column of Q and R and or S and P is false. Analysis. Construct table for the following. Number 1. PV not Q. The last column of P is F or false. The last column of Q is false. The last column of not Q is true. And the last column of P or not Q is true. Number 2. P and Q and not P. The last column of P is false. The last column of Q is false. The last column of if P then Q is true. The last column of not P is true. And the last column of P if P and then Q and not P is true. Number 3. If not P and V and Q and V and not P. The last column of P is false. The last column of Q is false. The last column of not Q is true. The last column of not P is true. The last column of not Q implication of P is false. The last column of Q or not P is true. And the last column of not if not Q then P or Q or not P is true.
Number 4. P and Q and R. Table. P. True, 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 true. False, 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 false. Q. True, true, false, false. True, true, false, false. R. True, false, true, false, true, false, true, false. Q and R. True, 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 false, true, 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 false. P and Q. True, 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 false. Number 5. Minus R minus P minus Q. Table. P. True, 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 true. False, 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 false. Q. True, true, false, false. True, true, false, false. R. True, false, true, false, true, false, true, false. Minus R. False, true, false, true, false, true, false, true. P to A. True, true, false, false, true, 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 true. Minus R and P minus Q. False, true, false, 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 true, false, true. Number 6. P and S, R and Q. Table. P. True, 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 true. Q. True, 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 false, 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 false. R. True, true, false, false, true, true, false, false. S. True, false, true, false, true, false, true, false. P and S. True, false, true, false, true, false, true, false. R and Q. True, true, false, 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 false. Number 7. Q and minus P and minus S. 2 R and Q. Table. P. True, true, false, false. Q. True, false, true, false. Notation Q. False, true, false, true. P and notation Q. False, true, false, false. P and notation Q and notation Q. False, true, false, false.
A proposition is either true or false. There are instances when a proposition is always true or is always false. In case all the substitution instances of an argument are all true, the argument is said to be tautologies or a tautology. A statement form that has only false substitution instances is said to be contradictory or a contradiction. Contingency is a statement form that has true and false substitution. Hence, contingency is neither a tautology nor a contradiction. Study the following examples. Example 1. Identify if P and Q is a tautology, contingency, or contradiction. The last column of P is false. The last column of Q is false. And the last column of P and Q is false. Therefore, it is a contingency since the propositional form is true and false. Another example is example 2. Identify if P or not P is tautology, contingency, or contradiction. The last column of P is false. The last column of not P is true. And the last column of P or not P is false. Since the propositional form is always false, then it is a contradiction. Example 3. Identify if P to Q to P is tautology, contingency, or contradiction. The last column of P is false. The last column of Q is false. The last column of Q to P is true. The last column of P to Q to P is true. Since the propositional form is always true, then it is tautology.
Abstraction. Identify if each of the following statement is a tautology, contingency, or contradiction by constructing truth table. Number 1. P implication to P, P, true, false, and implication P, false, true, and P implication and implicate to P equals false and true. Answer. The proposition of P implication to P is not always true. It is false when P is true. Therefore, it is a tautology. Number 2. Open parenthesis P conjunction Q close parenthesis implication P and true, true, false, false. Q true, false, true, false. P conjunction Q true, 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 false. Open parenthesis P conjunction Q close parenthesis implication P true, true, false, true. Answer. The proposition of open parenthesis P conjunction Q close parenthesis implication P is not always true. It is false when P is false and Q is true. Therefore, it is a tautology. Number 3. open parenthesis, P, implication Q, close parenthesis, conjunction, open parenthesis, Q, implication P, close parenthesis. P, true, true, false, false. Q, true, false, true, false. Implication P, false, false, true, true. Implication Q, false, true, false, true. Implication P, conjunction Q, true, false, true, true. Implication Q, conjunction P, true, true, false, true. Open parenthesis. Implication P, conjunction Q, close parenthesis, conjunction, and open parenthesis, in implication Q, close parenthesis P, true, false, false, true. Answer. Since the final column is always true, that statement is tautology. Number 4. Open parenthesis, P, implication Q, close parenthesis, conjunction, open parenthesis, P, implication Q, close parenthesis, conjunction. P, true, true, false, false. Q, true, false, true, false. Implication P, false, false, true, true. Implication P, conjunction Q, true, false, true, false. Phi, conjunction Q, true, 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 false. Open parenthesis, implication P, conjunction Q, close parenthesis, conjunction, open parenthesis, P, conjunction Q, close parenthesis, true, false, true, false. Answer. The proposition, close parenthesis, P, implication Q, close parenthesis, conjunction, open parenthesis, implication P, implication Q, close parenthesis, is not always true. Therefore, it is a contingency. Thank you.